Assalamu alaikum wa rahmatullahi wa barakatuhu. So in the today's video, we will continue with the synchronous motor. So today we will going to see how we can start the synchronous motor, as we have seen that the synchronous motors are not self-starting. Always remember that the rotor has got some inertia, and because of that inertia, that rotor cannot continue to move when we just give the three phase to the stator and three phase to the stator for producing the rotating magnetic field and the uniform magnetic field through DC source to the rotor. So in the because of the stator, the rotating magnetic field is rotating at synchronous speed. So that will actually try to repel when the north and south pole will be in front of each other, and they will try to attract each other, so they will produce a rocking effect, and the rotor will be shaking, just move to and fro motion. So this is how will happen, that it is rotating and north and south poles are changing continuously, and we try to apply the force on the uh, uh, rotor, but it will not it will not move at all. So this is how what happens with the if we don't have any mechanism for the starting of the rotor, starting of the synchronous motor. So in the beginning, what happens actually is, we can see at t is equal to 0. Here at t is equal to 0, we can see the stator magnetic field and the rotor magnetic fields are aligned with each other, and obviously there is no torque between them, so torque induced is 0. As soon as it will rotate in the counter, suppose we're taking it in the counterclockwise direction. So as the BS stator, because of the rotating magnetic field is rotating, so there will be certain angle between them, and there will be a torque on the motor in the counterclockwise direction. Similarly, again, if we are in a position that BR and BS are in the such that they are just 180 degree apart from each other, and then again because of this their angle is 180 degree, so torque induced will be 0. Again, when it will move further to this uh, uh, further to this uh, 270-degree angle, and here the torque induced will be clockwise, because it is BR cross product with BS. So if we will move from BR to BS, so according to that it will be having the torque in this rotor. So here we can see that in the one cycle, once the torque is in the counterclockwise direction, and then again it is in the clockwise direction, and then again when it will coincide with each other, BS and BR, so there will be no torque induced in the motor. So this is the relation that we have seen, BR cross product with BS. So that's why it will be rocking, and it will having a to and fro motion if we will not put some mechanism to rotate the rotor in the beginning. So how we can do it? There are three different methods that we can use to start the synchronous motor. The first method is a simple one, but obviously we need some other equipment, because the supply frequency is the fixed frequency. So we can use a cycloconverter or any inverter that have the capability to reduce the stator magnetic field, means we have to reduce the frequency of the supply frequency. So the first method says that they reduce the speed of the stator magnetic field, and that can only be done because we know that Ns is equal to 120 F by P. So F can be reduced. So to a low enough value that the rotor can accelerate and lock in with it during one half cycle of the magnetic field's rotation. This can be done by reducing the frequency of the applied electric power. So obviously we need some equipment to reduce this frequency, and that could be a cycloconverter or the inverter. So the second method is the use of an external prime mover. So this is a straightforward method. We can have any prime mover. We can have any other motor that is already running, or it could be induction motor, or any other way we can, or engine, or any prime mover that we can use, just like in the generator, to rotate it. So then what happens that external prime mover to accelerate the synchronous motor up to synchronous speed, then go through the paralleling procedure and bring the machine online as a generator. Then turning off or disconnecting the prime mover will make the synchronous machine a motor. So the third one is that's the most widely used is the damper windings, or called the amortiguer windings. So the function of the damper windings and their use in motor starting will be explained below. So actually this is the most widely used method to start the to make the self start of the synchronous motor. So by reducing the electrical frequency, what happens that if the stator magnetic fields is a synchronous motor rotate at a low enough speed, there will be no problem for the rotor to accelerate and to lock in with the stator magnetic field. So the speed of the stator magnetic fields can then be increased to operating speed by gradually increasing it up to its normal 50 or 60 Hz value. So approach to starting synchronous motors makes a lot of sense, but it does have one big problem. Where does the variable electrical frequency come from? So regular power system, as I have told you, that they are carefully regulated at 50 or 60 Hz. So until recently, any variable frequency voltage source had to come from a dedicated generator. Such a situation was obviously impractical except for very unusual circumstances. So today, obviously, the things are different. Solid state motor controllers can be used to convert a constant input frequency to any desired output frequency. So that's what we have talked, that we can use any cycloconverter or the inverters that have the capability of frequency variation. So with the development of modern solid-state variable frequency drive packages, it's perfectly possible to continuously control the electrical frequency applied to the motor all the way from the fraction of a hertz up to and above full rated frequency. So if such a variable frequency drive unit is included in a motor control unit circuit to achieve speed control, then starting the synchronous motor is very easy. Simply adjust the frequency to a very low value for starting, and then raise it up to the desired operating frequency for normal running. So what happens if we reduce the frequency? We can see that the internally generated voltage, which is equal to k phi omega, so that will be smaller. Obviously flux will be reduced, so the speed will be reduced. 2 pi f, omega is 2 pi f, so this will be reduced. If E is reduced in magnitude, then the terminal voltage applied to the motor must be reduced as well in order to keep the stator current at safe levels. So we also have to be careful that the terminal voltage also be reduced. The voltage in any variable frequency drive or variable frequency starter circuit must be roughly linearly with the applied frequency. So what happens the other method? In the other method, that is the motor starting with an external prime mover. So in this method, we will attach an external starting motor to it and bring the synchronous machine up to full speed with the external motor. So then the synchronous machine can be paralleled with its power system as a generator, and the starting motor can be detached from the shaft of the machine. Once the starting motor is turned off, the shaft of the machine slows down. The rotor magnetic field BR falls behind B net, and the synchronous machine starts to act as a motor. So once paralleling is complete, the synchronous motor can be loaded down in an ordinary fashion. So because we know that if it is running at a synchronous speed, so we can load the motor depending upon the depending upon the load requirement or the capability of the motor, that how much load that motor can support. So this whole procedure is not preposterous as it sounds, since many synchronous motors are parts of motor generator sets, and the synchronous machines in the motor generator set may be started with the other machine serving as a starting motor. So also the starting motor only needs to overcome the inertia of the synchronous machine without a load. So no load is attached until the motor is parallel to the power system. Since only the motor's inertia must be overcome, the starting motor can have a much smaller rating than the synchronous motor it starts. So because we have to just rotate it and we don't have to serve any load, so that's why we can use a very small motors that can rotate the synchronous motor up till the synchronous speed. So I hope you have understood so far. So we will continue with the synchronous motor in our videos, next videos. So if you have any questions, feel free to ask. Assalamu alaikum warahmatullahi wabarakatuh.